So, dear student, today I'll be discussing nanomaterials. So, let's see that. Yeah. So, nano, 10 power minus 9, right? So, mainly we will be using the nanomaterial application in medical industries. Okay, especially during surgeries and all, we have to see everything clearly. For that purpose, we will be using what? The tools, okay, which are made of nanoparticles. First, let's see the application because we should know why we are studying this. Nanofiber. So mostly it's used in the high absorbing diapers. Okay. And also during the molecular filtration, especially the RO filtration, all no, we'll be using this nanotechnology. Okay, so these two are the main important thing, and obviously the tissue engineering, as you can see in the pic itself. Nano sensor. Okay, so can you see here on some watch or band kind of thing? Correct? Yes. So these sensors will be able to detect the pulse in our body. Okay. And the output of this can be connected to another transmitter or receiver. Okay. So normally the one which transmits the signal is transmitter and the one which receives is the receiver. So the output can be connected to a receiver in this case. Okay. For example, a person who is wearing, let's take the Apple Watch. Okay, if I take the Apple or the any smartwatch, which can measure the pulse, the health. Okay, so what happens is that it will take the pulse signals through this particular sensor, that is nano sensor, and then if the pulse is stopped, of the there is a huge variation in pulse, it will alert us. Correct in the display itself that the heart rate is less. Okay, so that is the use of the nano sensor. Okay, and some more examples are sensors are detection of explosive. You have seen the bomb squads and everything, right? So all of this, so self-readable. All of these things are self-readable. So I hope you guys understood the basics of this. So now let's come back to the topic. Yeah. Surface area. Obviously, the surface area will be very, very less. That we already know. Correct. Then obviously, these nanoparticles are made of semiconductor and catalytic property. Obviously, it will increase the rate of the reaction. Then synthesis of nanomaterials, sol gel process. Metal, oxygen, and this R is nothing but the alkyl group. Okay, alkyl is nothing but CH3. If it reacts with water, what happens? One of the alkyl group is replaced by hydrogen. It will become ROH here. Then this MOH, the metal hydroxide, whatever it is, correct? This is converted into gel. These two will react to form what? MOM, the metal. Third one is aging of gel. Aging of gel in the sense, until the gel is if a liquid solid mass is purely converted to solid, we will wait for it to convert to solid fully. Removal of solvent. So any other liquid or vapor is there, we will be removing by heating. So that is called zero gel, the product. Then heat treatment. Again, it is dried by heating to up to 800 degrees Celsius. So high heating to get the nanoparticle. So these are advantages. Then another preparation method is precipitation method. Same thing. Okay, the metal with water. Correct. Then what I will be doing? You can see here, no, the metal insoluble salt with the metal hydrides. Then it's treated with sodium hydroxide to form what? Metal hydroxide. Like if metal is NaOH, then again it is heated to form nanoparticle. That's the thing. Nanofiber I just now discussed. Then liquid crystal. So as you can see here, solid, liquid, and liquid crystal is there. Correct. Temperature increasing. Classification. Two types: thermotropic and iotropic. Thermotropic is nothing but which exhibit the compounds which exhibit liquid crystal behavior. Okay, with the variation temperature is called thermotropic. So obviously, with respect to temperature, lyotropic is nothing but when one of the liquid crystal phase compound is treated with another substance. Okay, then it is called lyotropic crystals. Here, temperature down is basically simple soap water mixture, and that's an example. Another one also is there. So self-readable again. Thermotropic liquid. Nematic liquid crystal, cholesterolic liquid crystal, smetic, and DLC. That is discotic liquid crystal. Nematic is nothing but what? Thread-like. So they are optically inactive. Okay. So they got an elongated shape and parallel to director. I can see here. Let's zoom it. Chiral. Chiral means non-superimposable. Okay. So they are found by what? Optically active. First one, optically inactive. Third one, they are parallel to each other in a nematic base. DLC. There is an orientation order but no position order. So obviously the random motion of molecules is perpendicular to the plane. Properties. They exhibit what? Optical anisotropy. Then intermolecular forces are weak. Then they interact with electric field. Correct. And obviously there will be loss of positional order. Application. LCD screen, we'll be using it. Liquid crystal sensor. Optical communication, optical fiber. There's a lot of other things. So again, you can just write it in your own words. OLED. LED is nothing but light emitting diode. Okay. So OLED is nothing but if I apply current, it will emit light. That's the thing. Then properties. Self-emission property. They are solid in nature. Okay. So the response time of OLED is as fast as micro or nanosecond. It is in per minus 9. Then it is used in where TFT, thin film transistor. Okay. So due to the use of TFT, high information content is possible in OLED display. Application LED, we all know: TV, camera, mobile phone. That is liquid LCD, liquid crystal display. And there are some TVs, LED TVs, and everything. Those things. Then quantum light emitting diodes. So quantum light emitting diodes are having higher brightness, higher efficiency. So all of these same things you can write in the previous thing also. No one is going to check it. Application, electronic devices. Anything you can check it with what? Electronic devices. Okay. Last one. Perovskite metal. So it is a three-dimensional ABX, where A is organic cation, commonly what? Methyl ammonium cation, and B is metal cation, and X is a halide, halogen, as already I think you guys know it. Properties, same thing as previous: low cost production, fast return efficiency, all of these things will be same. So that's it with the nanomaterial. So thank you so much, guys. Have a great day.